So we're about to start. All right, here we go. Hello, everyone. Ready, Habib?
Yeah. Hi, everyone. Good day.
Hello, and welcome, everyone. My name is Theodor, Theodor Dimake, and thank you for joining us today. We're we're live, and I'm the director of AI and data here at Minded, and we're helping teams build real data and AI products and solutions from prototyping up to production and scaling. And we're joined here today with Habib from Microsoft, Habib Selman. Hi. Can you tell us a bit about you, Habib?
Hi again, everyone. I think I've been cut out for a moment, but I hope everyone can hear me well. Just let us know in the chat if everything is fine. So I'm Habib, working at Microsoft in the data analytics space. My main focus has been helping, customer design and build solutions all around the Azure data portfolio, and lately mainly on Microsoft Fabric, and doing different use cases in real-time intelligence, but also advanced analytics. So a lot of my work has been really helping customer to move beyond traditional batch-oriented architecture and also understand what becomes possible when insights are being available in seconds or milliseconds, right? So
Yeah.
yeah, Fabric is the way to go.
All right. Thank you, Habib. Yes, speed. Speed is very important, right? How fast the data turns into insight. And it comes up more and more in our discussions with most of our customers. So that's why today's topic, real-time intelligence in Microsoft Fabric, is so relevant. So we'll let's say highlight the agenda. We'll be handing it over to Habib for the for discussing the Microsoft Fabric solutions for real-time analytics. And Habib also has a surprise install for us. He has a real-time demo, and then we'll be looking at some of our highlights and what we found working with our customers throughout the years. So yeah, without further ado, Habib, floor is
Yeah,
yours. Let's start.
thank you. Let's go. So yeah, I mean, I'm really interested also to see later how our customers or joint customer do. But let me quickly here start my sharing. So I have this already set up, and you know. Um, There has been a lot of change. Lately on how through time uh, we've been working, right? So historically, we've really relied on pipelines to move data into lake houses, build semantic models on top of it, and then consume everything in Power BI. That's basically how our data platform are built, right? And that's the default thought usually, but it's still also the center. I mean, it's still also the still valid, right? Power BI is also still valid when you have a batch scenario, but the challenge of this approach doesn't always really fit every business scenario, right? So sometimes the business really wants to know what's happened yesterday, or even not only like what happened yesterday or an hour ago, but we want to know what's happening now, right? So really in some seconds, and even sometimes in milliseconds frame, right? So And that's where the difference, or the main difference, come with when we compare it with traditional batch-based architectures, right? So if we follow that pattern usually, and we do a real-time scenario using a normal batch architecture, we end up having a lot of notebooks start running continuously, right? We have a lot of pipelines overhead. The lake houses will end up with having small transactions, which usually is not a good sign, right? And when this scales, it becomes very expensive, right? It became even very hard to govern and even harder to operate. And this pattern have been seen some customers, and that's exactly actually why in those scenario real-time intelligence also exists in Microsoft Fabric, right? So um, so real-time intelligence, really is a set of capabilities that basically are really that is part of the Microsoft Fabric suite, right? So if I come here, so basically we have the traditional Microsoft Fabric workloads, and then when we pick real-time intelligence, we have different workloads we will use, right? So and here we're talking usually in the millisecond frame, all right? So from the moment an event is being generated, if it can be a sensor data, it can be log, API call, to the moment it becomes really visible, we want to have actions. So when it's visible, I want first to query it. And also, I want to do actions, right? Since that's basically the fundamental change now, how you design your solutions at the end, right? So I have this makes conceptually some sense, right? So I hope that also at least with the demo I'll present, you will understand a bit why real-time intelligence also is important. Because if you imagine yourself, if you're, for example, an Azure administrator, you're managing maybe hundreds of virtual machines, and usually everything is fine until nothing is really fine, right? So like the CPU usage spikes to 95%, for example, right? You don't want to find this out tomorrow, right? You don't even want to wait 10 minutes. You want to know this now while it's happening. So you can really react on it, right? And the same patterns actually follows IoT devices, manufacturing, financial systems, right? If you have fraud detection, you want, if any event is happening and can have an immediate business impact, that's real-time intelligence when it really comes into play, because it will allow you to be reactive, and I mean, instead of being reactive, to be more proactive, right? And that's exactly what I want to show you now, right? And I think we'll have here, just a use case where we are a manufacturing facility, right? We have we are monitoring two machines, so we have a robotic arm and a packaging line. And the idea is, and the goal is very simple. I try to keep it as simple as possible. We want to detect issues very early. We want to understand what's happening immediately, and we also want to react automatically when something goes wrong. And we'll see also how simple it is. We all also, of course, the idea is to stay in the same platform, which is Microsoft Fabric in this case, right? Let me here get this here. I'll just reshare my screen, and I will add this small. I hope it's big enough. Otherwise, I will just zoom in a bit. All right, great. So before I start, basically, and I want basically I want basically the solution and the setup will get basically a couple of things done, right? So I imagine you are a manager or someone who really wants to have a quick answers without asking IT, right? So you have already all your data, your sensor data coming. They just want to have really and do some queries that run instantly on the KQL, right? And this is a scenario where you would use, for example, data agents, right? So you will not need necessarily, to wait for your engineers or to wait for your analysts to create some reports, right? So, for example, I can ask a simple question like this, what's the total production volume over the last 3 months, right? And simple as it is, actually, the plain English text will be then translated to a KQL query, and this KQL query will run on my tables here, added, right? So maybe actually you see here, for example, we have a response like around 76K units, and the good thing also, you get the query that's behind it, and you can even test it as well. We'll do that in a moment, right? Um, I just want to get back quickly here to the architecture of the whole setup to see how simple this is, right? So basically, behind this data agent, we have our telemetry data simulator. So it's just a Python code that's running behind it, running now locally. And I even made it even more simple. I took this Azure Event Hub out, and basically I'm just directly ingesting the data into my event stream, right? So my event stream is basically what's used for ingestion and do some transformation on the fly. Then this data will be ingested into my event house as my sink, and event house is where my custo database is sitting. So the event house is kind of a workspace container where you have your different databases. And then for real-time dashboarding, we have real-time dashboard that will automatically refresh as the moment the data arrives. I mean, this is very, very powerful, right? Then of course, we want to have actions when the data comes. So we have the activator that every time it detects an anomaly, a notification will be sent, right? So basically here where we have our alert triggers, when we have our actions based on, for example, based on any anomaly that happens. Let me ask, for example, another question first to my agent. For example, we have two assets, right? And I want to know which one has been more profitable. Maybe um, as the line of business manager, or the manager and the manufacturing there. And just as a small thing, you know that usually this is the way to go when you want you add Azure instructions, so you avoid any hallucination. You ground it on your data. You give it clear prompts. You explain also some key business terminologies. Give it also things to do and things not to do, like for example here, complex statements, so you really kind of keep it clear. And also some KQL examples, queries to run, right? And you see here really in a couple of seconds, I get, for example, my response, which asset has been more profitable in this case. It's the first one, and the same, I get my around here. So you get even like here a complete table that you can use. So yeah, you might be someone that wants to have also a look over your whole dashboard, right? You need to have some historical data there, right? So here is a place, to go, for example. I have here my real-time dashboard. The advantage of it, right? So you can decide what's the refresh rate you want to have here, right? So in this case, we're having a continuous refresh. So literally when something comes in, we're going to have it here displayed. And all of these visuals are actually queries, right? So if I look around here and I open my query, you see these are normal KQL queries that you run and are also being processed on the fly. And this is actually also the power of the KQL databases. They are really powerful, performant, because they rely on hot data, on caching as well, and also you can see this to come to the limits of a KQL database is quite hard, but usually this is of course our way to go when you want to have real-time intelligence. um, I want to show you then how is the data coming, right? So I'll just take a step back here to start from where, for example, as let's say an engineer or a fabric developer wants to start building his POC or his solution. We start from the event stream, right? So the event stream is how you would ingest your data, and this is really a low code, no code solution to really let me here change from live to the editing mode. So I can show you here the different data sources you can. So you have custom endpoints, right? So these custom endpoints, you have the possibility basically you have event hub, Kafka, and also different data sources beyond your custom endpoint that is already there. For instance, if you have IoT hub, if you have even let's say Azure Service Bus, right? Even if you have an HTTP connector, right? It's something you can already connect to your event stream, right? And this goes beyond that, right? So, like I said, if you have some event blob storage, also you can do this with Fabric event. For instance, if you want to see some capacity overview, and also if you want to do some job events tracking for your Spark, and also if you're using OneLake as your storage data source, right? So you see, you have this simplicity to directly start building using the built-in course. And also, what you can do is some transformation on the fly. So very simple. By filtering, you also manage your fields, do some aggregations. And at the same time, you decide you use it. You use it, for example, your event house to sync your data. Um, while we're talking about the event house, right? So let's have a look there. And all right. So like I said, your event house is the place where your data resides, right? So you can have as many KQL databases as you want. So you can of course query it via your SDK. You can of course also, for instance, the monitoring you have here. So basically, here is a place where you would have an overview about the storage, the activities. So you really can how is it performing and how things are doing. If I click here to my KQL database, I get another view where I can track the data activities. I see here my tables. I can also create some materialized view that I can use. And in our case here, I mean, I really kept it very simple due to the sake of time. But you see, I'm just some endpoint sending my data there in a JSON format and then directly route it to my KQL database. And if something happens, an action would happen, right? Um, so basically, if I get back to my KQL database, and let's say you would like to to have a medallion architecture built into your database, right? And it's something that you definitely can do, right? So you can also create some tables or some staging tables for for your silver, gold, and then you can do the transformation, and then you can have a complete lineage of your database and of your transformations around here. And another thing, right? So this data is here. You can with one click make it also searchable. You can find it in one lake. If you want to use this information, let's say for training a data model, a machine learning model, or if you want to add it to a lake house, for example, via shortcut. And the same is different, of course, right? So you can also add. All right. One last thing, Stay, I want to show you, and let's get back here to our let's simulate an anomaly, for example. I Now it should be simulated in a moment. For example, um, I think I simulated the robotic arm. Normally, should be in a moment turning red. Uh, I think. Uh, well, well, it's fine. I think I don't want to lose here too much time. But basically, I think I have an issue with my small simulator, but we can simulate it differently. It's different. But actually, you can see here these small peaks there where I had some anomalies basically already happening, either by defect probability here, for example, or here in this part where I have some vibration that fell down, right? But let's say that an anomaly happened in real time. Um, we can here use the activator, right? So basically, when, for example, a condition is met, either about profitability or if we have high speed, high vibration, for example, if it comes to a specific value, and you can have also multiple conditions, for example, right? And I let's discard these changes and let's test this one out, for example. And for instance, if I test it here out and this condition is being met, then what I will get is an email notification, right? So let's have a look until it opens. So one of the actions can be a Teams notification. You can start an activity, one of these, you can start a function. And also what you could do, for example, is a Power Automate flow, maybe to trigger another flow, so maintenance starts, for example. And here you see actually all the emails I got. Of course, it should not be like this, but you get this type of notification, and the same can be done in Teams, for example, right? So this is basically, and I hope that it gave you here the difference and also some feeling how you can start using real-time intelligence in comparison, for example, from batch processing. I want maybe here by one maybe last question to or one last query I can send to my data agent. I can ask it, for example, if there is a connection between speed and quality, right? And this would basically show us by the response that there is some correlation between the root and cause, right? So it can also explain the causes, not just report the numbers. And I think this is very valuable at some point, right? So yeah, so you get here a kind of a correlation, for example, and I think with that, I think we had a very brief introduction and explanation about how this looks like, right? And I'm very curious to maybe hear from you, Theodore, how you at Minded deal with it with your customer. What's your journey? What you see at your current project?
Thank you, Habib. Yes, this is all very insightful, and I'm happy to see all of this new technology coming to the aid of everyone here. And I have to say I'm a bit, let's say, jealous that we didn't have this kind of technology when we started working with trying to get real-time intelligence with our customers. And sharing from our experience, let me just quickly share my screen as well. Okay, this is a real live use case and real success story with a customer of ours, a global travel retailer. And what you said, Habib, really connects to my own experience as well. So I've spent most of my career building data platforms, and when people talk about real time, my default thinking and point of reference is still pipelines, right? The ETL of the past. Azure Data Factory, integration service, or whatever that may be, and even today's data flows and pipelines in Fabric or other tools like Databricks. And these approaches clearly have worked and will work as well, but they remain important, but are largely batch driven, right? So the key question I keep coming back to is, are we just optimizing batch processing, or is there a fundamentally different way to design data products when speed actually matters, right? So that's what we're talking about. And this is one of the success stories that we want to share with you today, and that aligns to very well with what you told us here, Habib. So this you see the numbers on the screen, right? This is a global travel retailer with one of the world's largest lake houses in retail, thousands of stores, global span, and really, we've been their partner for over a decade now. We've built platforms from scratch, starting on premise, and we're still evolving it as we speak. And essentially, let me change the slide. It all came down to like three eras if we're going down memory lane. So we started on premise. We started with again Microsoft technology, but SQL Server, integration services, analysis services, and the like, with the classic nightly batch loads. Right, we were waiting for those multi-hour batch loads to run every night, and everybody was waiting for their fresh data in the next morning. And that worked for several years. And then came the second era. We moved to Azure. The company went through a major merger, and that doubled the number of data, doubled the number of stores, the number of data points, but it was still batched. We managed to refresh every 2 hours. And the number of reports was now hundreds of reports to thousands of users. We had, I think, over 500 weekly users and thousands no, sorry, 500 daily users and thousands of weekly and monthly users. And the platform was clearly successful. Everybody was using it, but the cracks started forming. Everybody wanted more and more up-to-date data. And number three era was the payoff. That's when we moved to the lakehouse architecture, not just for the data model, but we also needed the streaming alongside the batch. This was a whole different paradigm. And the 2 hour refresh batch needs to be taken care of, right? We need streaming data, no longer batch. And from 2 hours, that was the gap, right, between data refreshes. And the business teams running supply chain dashboards across thousands of stores could not wait, right? They were making operational decisions on already stale data. And they need to scale. They need faster access to even more tens of terabytes of data. And this bottleneck spanned across different domains. We've also absorbed the data mesh architecture, and we have over 6 domains, each vying for, each saying they're more important, each wanting their own data faster, and this, hits hard. The shift was in to move from hours to minutes or seconds. And the streaming data alongside the batch proved was the way to do it. And now the domain teams in the data mesh architecture were owning their data. And we also had this unified governance across everything we've built. So clearly the batch architecture worked until it didn't, right?
Yeah,
And
agree on that.
yeah, and these are, let's say, this is a simplified view of the let's say 3 blocks that we had, right? We have the data sources on the left. We had over 30 different data sources to ingest from, including the most important, which were the point of sale systems. Um, and we had also a mix of customer relationship management platforms and different ERP systems, NoSQL databases, and in the middle you see the 2 parallel lanes. Batch still runs, right? We still need maybe some sophisticated methods of querying data that streaming just doesn't cannot take care of in seconds, but streaming runs alongside it, and both feed the same lake house. And the different tiers in the medallion architecture, let's say bronze, silver, and gold, which everybody's now familiar with. And on the right-hand side are the consumers, right? You have a different mix of dashboard. You have also the classical reports that are sent via email in the top management's email every Monday morning or every day. But you also have the operational dashboards that everybody wants to access from their laptops, from their phones even, and they do it more and more often. But you also have the machine learning models that now also require, right, data scientists, and the AI team requires fresh data to work with and train the machine learning models that will be deployed uh, in the intelligence community. And you have the domain teams, right? Or again, the data mesh architecture requires a different expertise and different domain teams. and you have all other external apps that are connected to this. And we know because we've been partners with them for over a decade, and we've built all sorts of applications down the line, and these applications require data as well. So we didn't just throw away the batch, right? We just added a streaming layer as a parallel capability, right? That's essentially the unlock. So in the end, what we achieved, right? The domain autonomy that I mentioned, the teams own their data end to end. We added the streaming layer alongside the batch one, using the Kappa architecture. For those of you who are familiar, no replacing, just adding alongside it. The streaming was additive. We made it machine learning ready, native platform, not bolted on, with unified governance across all layers and all domains. So the pattern is autonomy, speed, intelligence, and governance in the end. And this all connects to, and I wish, right, this kind of technology that you showed us, Habib, today was available earlier, because we've built all of this, you know, using a lot of effort. This was all a lot of custom and transitions, as you've seen, from on-premise days to cloud, and then from cloud to the medallion architecture and more recent technologies. We're using structure streaming, hand-coded ingestion pipelines, custom monitoring. So it took years and significant engineering to do all of this. What excites me about what you showed us, the Fabric real-time intelligence, is that much of what we built custom is now available, a lot of it available out of the box. Um, so, right, hand-built streaming data hub to managed real-time hub, the custom alerting and monitoring to built-in rules and actions, the domain-specific dashboards to real-time dashboards with the Custo query language that you showed us. So, same journey, but a faster path, really, to success. And if you're just starting on this journey today, you don't have to build it the hard way. Fabric is one very important tool that's available to us from today onwards. So yeah, this was just one example. There are more. This is across industries. Another leading European food distributor with over 9,000 point of sale systems, mobile point of sale system, mind you, across the DACH region. They want real-time information as well. And we've lowered this from 30 minutes to under 40 seconds with a delta refresh. So everybody's looking for speed, essentially. And the line between fast batch and real time is blurring. And essentially, right, with that, Habib, I think we should open up for questions.
Absolutely. I mean, we already have some questions I saw in the Q&A, and I'm trying to answer some of them. But I saw I already typed a couple. I'll just pick one
Mm-hmm.
question from Michael or Michael. So how does Fabric real-time intelligence handle governance? I'm asking about when we have multiple teams, uh, when we have multiple teams consuming the same stream, right?
Mm-hmm.
So with that, so basically, Fabric really handles governance by, you can manage basically access, permissions, views, the same as you would basically with each workload, right? So you have the possibility, for example, to share these permissions, to give some the same roles as your used basically to do with other workloads. So the same concepts, for example, when you have a semantic model, you want to share it. The same also would apply. So basically, you can give access to people in the workspace level, right? And yeah, I hope this kind of helps. So basically, um, your workspace will be the place where you want to control that for the event stream at least.
Hmm. Yeah, the catalog is essentially the key pillar here, and you know, in Microsoft you have the purview, and in the Databricks space there's the Unity catalog, and from our experience, you know, the governance isn't the cost of doing real time, it's the enabler actually, and
Hmm.
again from our experience, we couldn't scale to over 6 different domains without a catalog like Unity Catalog or Microsoft Purview. So without governance, you know, domain autonomy becomes, you know, chaos. So yeah, thank you for the question. And just to point out the fact that we also have a quick um, a quick questions and answers link for you for feedback to the session. It will take you just a few seconds to fill it in, under a minute. So we would appreciate the feedback.
Hmm. Please, yeah, use the feedback. Do we have still time to answer the questions? Otherwise, I will
Yeah,
type some of them. I already tried to type some of them. I'll pick another one I didn't answer.
yeah.
From
Let's pick another
Beatrice,
one. Hmm.
where does AI fit into real-time intelligence? And is this about dashboards today and AI tomorrow, or can they work together from the start? I mean, personally, I would say AI would fit from day one, right? If you're talking about real time, really, it will tells you basically what's happening now. And here, AI could help, as we saw, to explain it, summarize it, to answer some question about it, and they work hand in hand, right? So
Hmm.
I think when it's about streaming data, for instance, or also batch data, when you have your data ready and you can use it to ground the AI to have maybe a multi-agent framework to use it, for example, in a broader context. And here comes, for example, something what we call in Fabric, the Fabric IQ. So basically, you have different tables coming from different line of business, and you can connect them, for example, through metadata to build what we call an ontology, right? And when you feed
Hmm.
it to an AI system, for example, you would give it the possibility to not answer, for example, like in our case, only about the numbers, but if you give it another context about the why, for example, to explain, for example, if this maintenance issue is coming, let's say, because of specific code, you can basically give your business users the possibility to query the data, understand the why, and what are the possible things you could do, right? So
Hmm. For
this
sure.
is my
Thank you.
short answer. Yeah,
It's compounding, right? It's
yeah.
real-time data plus AI. You know, you make proactive decisions, and adding, as you said, agentic AI leads to autonomous actions. So of course, you don't need AI to start with real-time intelligence, but real-time intelligence makes your AI even more valuable, right? And um, yeah, you don't need to wait for AI to justify real time, but knowing that real time is a prerequisite for AI, it's very impactful for sure. Okay. Do you have any other questions? Okay. See, some were answered. Most were answered in the chat. I don't think we have any. Okay. Yeah, exactly. Custo query. Yeah, I was looking at the same question. Yeah, it's approachable. I could say SQL is my let's say I have the native language and it's English, then SQL is my third language. But Kusto, yes, yes, I can say it's very approachable. Yeah. All right. I think that is all. Thank you. Yeah. Do we have this? Okay. Yeah, I think we answered all of them. Okay. If there are no more questions, then I guess we can wrap it up. Thank you, everyone, for attending our webinar today. Thank you, Habib, for joining us today and for sharing all of your wonderful tools and work at Microsoft with Fabric. It's very exciting to see what's available
Exciting
now.
moment. Yeah.
Yes, exciting times as well. Thank you, everyone.
Thanks.
Have a great day and a great start of the week.